So Ruby on Rails.
Yeah, the name itself brings up ideas of speed, right? Elegance?
Definitely.
Yeah.
Getting ideas from concept to code, like really fast.
It hit the scene back in 2004, promising to make web development genuinely enjoyable.
And for many, it absolutely delivered. You look at early adopters, GitHub, Airbnb,
Yeah.
huge successes built on it.
For sure. But, building that initial app may be something smaller.
That's one phase.
Taking it all the way to a big, stable application, handling serious production traffic.
That journey, well, it introduces a different set of complexities, doesn't it?
It absolutely does. Challenges you might not even foresee when you're first starting out.
Right, and exploring those hurdles is exactly what this deep dive is about. We've pulled together quite a bit of material.
Yeah, we've looked at blogs from places really deep in the ecosystem like Cloud66, Pro5.ai,
Dug through those Reddit threads where developers really hash things out.
and checked out tutorials on essential tools like Selenium for testing.
Our mission here is to sort of cut through the noise, pull out the key insights you need to understand what it really takes.
What it takes to build, deploy, and importantly, scale a Rails app successfully today.
We'll walk through the, let's call them development headaches first.
And the whole process of actually getting it into production, which is its own beast.
Definitely. And tackle that big question, does Rails actually scale? There's a lot of debate there.
And finally, look at where crucial practices like testing, maybe with Selenium, fit into the picture.
Okay, so before we dive into the problems, let's just quickly touch on why people loved Rails so much in the first place. What was the appeal?
Looking at those Reddit discussions, flexibility is a big one.
Flexibility, how?
Well, the modular structure, the whole ecosystem of gems, it makes modifying things or adding features later feel, well, less disruptive, more adaptable.
And the conventions, the Rails way.
That standardization, while maybe a bit opinionated for some, it does promote consistency, which helps with stability, maybe even performance, by guiding you towards certain patterns.
You mentioned gems. The sheer number of available libraries is incredible.
It really is. Need payments,
Yeah.
background jobs. There's probably a well-tested gem that saves you, like, weeks of effort.
That's huge for speed and deployment. Initially, that was seen as a plus too, right?
Yeah, the framework encourages principles like DRY, don't repeat yourself. Less redundant code, often easier initial deployments.
Plus, automation tools made getting that first version out feel pretty smooth,
And it's mature technology now. It's been around since 2004.
which means a massive community, tons of documentation,
Exactly. You get stuck. Someone's probably solved it before.
and built-in security features. That's a big one too.
Definitely. Protections against common things like SQL injection, XSS, CSRF are baked in. You still need to use them right, but they're there.
Okay, so a really strong set of reasons to choose it. But like you said, those strengths can sometimes lead to challenges down the road.
That's the trade-off often. Rapid development speed is great, but the runtime speed. Ruby can be slower than, say, Go or Java.
Not always noticeable at first, but under heavy load.
It becomes a factor, yeah. Needs more resources, potentially.
And those conventions. The Rails way.
Super helpful if you like it. But if it doesn't fit your style or project,
It can feel restrictive. It has opinions.
strong opinions.
Yeah.
And the gems, while amazing.
Can also be a management headache.
Right. Choosing the right one, checking security, managing compatibility across dozens, maybe hundreds of gems.
Yeah.
It takes effort, requires diligence.
Okay, that sets the scene. Let's unpack those development headaches. What trips people up while they're building? Performance often comes up early.
Oh, yeah. The abstraction that makes Rails great can hide performance issues. You write simple-looking code.
Bam, it does something super inefficient underneath.
Exactly. Especially with the database. The classic N+1 query problem is a perfect example.
The N+1.
Right.
Fetch a list, then loop and fetch related data for each item. One query becomes, like, 50 queries.
Precisely. Or slow view rendering, or trying to load massive amounts of data at once.
So how do you fight that in the code?
Careful database work is key. Optimizing queries, using eager loading to grab associated data up front.
Instead of later, in a loop.
Right. Sometimes you might even need to write custom SQL. And tools like the bullet gem are super helpful for spotting those N+1s.
What else? Caching.
Caching is fundamental. Rails has fragment caching for views, low-level caching for data, often using things like memcached or Redis.
In-memory stores for speed.
Exactly. And you absolutely have to profile your code. Use tools like Rack Mini Profiler locally or New Relic, Scout OPM in production.
To find out where the time is actually being spent.
You can't optimize what you don't measure.
Okay, performance is one thing. Database migrations. Changing the database schema over time. That gets tricky too, right?
Oh, definitely. Especially in production. A bad migration can cause downtime or even data loss. It's high stakes.
So meticulous planning.
Absolutely critical. Understand the impact, break big changes into smaller steps. Tools like strong migrations can prevent you from doing obviously risky things.
Like dropping a column without handling it correctly first.
Exactly. And you need to test migrations thoroughly in a staging environment that looks just like production. No shortcuts.
Testing in general feels extra critical for Ruby because it's interpreted.
That's a huge point. No compiler catching basic typos or syntax errors before runtime.
So your test suite is your main line of defense against shipping broken code.
It is, but the challenge is, as the app grows, the test suite itself can become a problem. Slow, flaky, hard to maintain.
Yeah, if tests take 30 minutes to run, developers start looking for ways to skip them.
Which defeats the purpose. The key is a balanced approach. Lots of fast unit tests, fewer integration tests, just a few end-to-end tests.
A testing pyramid.
Exactly. Using frameworks like RSpec or Minitest, tools like Capybara for the browser tests. And you need to refactor tests, keep them clean.
And run them faster.
Yes. Run them in parallel. Tools like parallel tests or features in your CI/CD pipelines, Circle CII, GitHub Actions are essential. Automate everything.
Okay, what about managing all those gems we rely on?
Dependency management. It's a constant task. Every gem is a potential source of conflicts, security holes, or compatibility pain.
Especially when upgrading Rails itself.
Oh, yeah. You need regular audits. Use tools like Bundler Audit to check for known vulnerabilities.
And lockdown versions.
Absolutely. Rely on your gemfile.lock. That ensures everyone and your servers use the exact same versions. Tools like Dependabot help automate checking for updates.
But you still need to test those updates carefully.
Always. Blindly updating can break things unexpectedly.
Security isn't just the framework's job either, is it? Developers have a role during coding.
A huge role. Rails provides defenses like CSRF protection, but you need to make sure they're enabled and configured. Using strong parameters correctly is vital.
To prevent users from sneaking in unexpected data.
Exactly. Mass assignment vulnerabilities. And running security scanners like Brakeman, keeping gems updated. It's ongoing vigilance.
What about the front end? Assets like CSS, JavaScript, images?
They can definitely become a bottleneck. Poor management means slow page loads, bad user experience.
So use the asset pipeline.
Use the asset pipeline or maybe Webpacker if you're heavy into modern JS frameworks like React. Compile, minify, compress.
And cache aggressively.
Cache in Rails, cache with a CDN like Cloudflare or Fastly. Optimize images too. Every little bit helps perceived performance.
And then there's legacy code, the elephant in many code bases.
The reality of long-lived projects, dealing with code that's old, maybe poorly documented, definitely lacking tests.
Refactoring that feels risky.
It is, especially without tests to tell you if you broke something. The key is incremental improvement.
Little bits at a time.
Yeah, refactor small sections, improve docs as you go. Add tests to critical areas before you touch them. That builds confidence.
And plan upgrades carefully, not one giant leap.
Definitely. Incremental Rails version upgrades are much safer.
Okay, that covers a lot of the in-code challenges. Now, let's talk about actually getting this thing live. The deployment gauntlet.
This is where, according to sources like Cloud66, things get really interesting and often painful, especially with the cloud.
How so? The shift from old-school dedicated servers.
It's a fundamental mismatch. Older tools, like maybe Capistrano, were often built assuming servers were static. Fixed IP, fixed hostname.
But cloud servers are dynamic. They appear, disappear, change IPs.
Exactly. Making those traditional tools work reliably in that dynamic environment often involves complex, brittle scripting or plugins. It's fighting the model.
And just setting up one server sounds like a ton of work if you do it manually.
It's huge. Provisioning, RS updates, installing Ruby, Nginx, database drivers, libraries, configuring everything, setting up monitoring, logging.
And then keeping it all patched and secure forever.
It's a massive ongoing job. Kernel updates, package exploits. Developers often don't have deep ops expertise, and relying on a separate ops team can create bottlenecks.
The source mentioned even tools like Chef or Puppet don't magically solve it.
Right. They help automate, but you still have to write and maintain the complex automation scripts for them. And those scripts can break if underlying things change.
So managing your own infrastructure requires significant Continuous effort and expertise.
No question. It's not just setup, it's long-term vigilance.
And the asset pipeline we discussed.
More challenges at deploy time.
Yeah, debugging asset compilation on a production server is not fun.
Right.
The advice is solid. Don't compile assets on demand in production. Compile them once during deployment, maybe on one build server.
And then push them somewhere else.
Push the compiled assets to a CDN or cloud storage like S3, using something like the Asset Sync gem. Takes load off your app servers, improves performance.
Makes sense.
Yeah.
What about the reverse proxy, like Nginx, managing that as you scale?
Get complex. Beyond one server, Nginx needs to know where to send requests, how to serve static files directly.
As you add or remove app servers, Nginx needs to know about them. Exactly. You need automation, maybe a load balancer handles it, or your config management tool updates Nginx, but it needs careful setup and tuning.
And production infrastructure security.
Yeah.
That's way beyond just application code security.
Oh, vastly. Firewalls, patching the OS and services constantly, intrusion detection, managing IP blacklists.
It's easy to skip steps when you're rushing to launch.
But that catches up to you. Real infrastructure security takes dedicated focus and expertise.
High availability. Keeping the app up during deployments, or if a server fails, that becomes critical.
Users expect services to just be there. Downtime for deployments isn't acceptable anymore for most apps.
So you need zero downtime strategies.
Right. Things like rolling updates, where you update servers one by one, or parallel deploys if your app can handle it,
Or more complex things like blue-green deployments.
where you spin up a whole new identical environment, test it, then flip the traffic,
Well-
all require serious investment in reliable automation and testing.
And trying to use multiple cloud vendors for resilience.
Adds another huge layer of complexity. Maintaining deployment automation across AWS, Google Cloud, Azure, it's really hard to do well, requires constant upkeep.
It really sounds like managing all this yourself is a massive challenge for many teams. The Cloud 66 source drives that home.
It really does, and understandably, their perspective is that teams should offload this operational burden.
To a specialized platform.
Exactly. A platform designed to handle the deployment, the scaling, the security, the databases, the proxies, maybe even Docker containers.
The pitch being, let developers focus on building the app, not managing servers.
That's the core idea. Let someone else handle the infrastructure complexity.
Okay, so dev challenges, deployment complexities, which leads us straight into that big thorny question, scalability. Rails doesn't scale. We hear that a lot.
We do, and that Reddit thread we looked at really captured the back and forth.
What are the common criticisms you hear?
Usually it's things like Ruby uses a lot of memory, Ruby itself is perceived as slow, you have to use background workers for everything, and Rails pushes you towards a big monolithic app.
And those points can sound pretty damning if you're new to it.
They can, but the experienced folks in that thread push back hard. Their main point: Rails scales just fine.
Okay. How do they justify that?
They argue scaling is hard, period. For any framework, it's about engineering architecture, monitoring, benchmarking, optimizing, not just the framework choice.
So it's less about Rails itself and more about how you use it and build around it.
Precisely. Many Rails performance problems are actually programming errors, loading way too much data, N+1 queries again.
Things that would be slow anywhere.
Or database bottlenecks. Slow queries, missing indexes. The database is often the real bottleneck, not Rails. Database tuning is key for any stack.
What about needing background workers? Isn't that proof Rails is slow?
Not really. Offloading long tasks, sending email, processing images to background jobs is standard practice in all modern web frameworks. It keeps the main web requests fast and responsive.
It's just good architecture.
Right. And scaling those workers is way easier now with cloud auto-scaling. It's mostly configuration.
And the monolith argument. Rails does encourage that single app structure.
It does. But the counter-argument is that a well-structured monolith isn't necessarily bad, especially early on. It's often faster to develop in and easier to manage initially.
Compared to microservices.
Yeah, microservices bring their own massive complexity, deployment, communication, distributed tracing. It's a major trade-off, not always better.
And are these scaling issues really unique to Rails anyway?
The consensus seems to be no. Frameworks in similar interpreted languages like Django with Python, Laravel with PHP face very similar challenges. Database issues, caching needs, background tasks. The patterns are common.
So that Rails doesn't scale line. It's really an oversimplification.
A major one. Rails does scale. Shopify, GitHub, Airbnb are proof. The real trade-off, often, is that Rails optimizes for developer productivity and iteration speed.
Getting features out fast.
Exactly. which might mean it uses more resources or is less runtime efficient per request compared to something like Go optimized purely for raw speed.
So you're choosing developer speed now, potentially higher infrastructure costs, or more optimization effort later.
Kind of. Or you're choosing to tackle scaling using well-known patterns when you get there. The experienced developers emphasize success relies on architecture, aggressive caching, smart background job use, deep database optimization.
Those things matter more than the framework itself.
By far. They determine your ability to scale much more than just picking Rails or something else.
That definitely reframes the discussion. Okay, last major area. We've hit dev, deploy, scale. Let's talk about a key practice. Testing, specifically functional testing with Selenium.
Testing is so critical in Rails, again, because it's interpreted no compiler safety net.
Your tests are what catch bugs before users do.
Absolutely. And Selenium is a major tool for a specific kind of testing.
Browser automation.
Exactly, functional testing. Selenium lets you write scripts that actually drive a real web browser, click buttons, fill forms, check results.
So you're testing the whole stack from the user's perspective.
Precisely. The main piece is Selenium WebDriver. It talks directly to the browser using its native automation support, and you can write tests in Ruby, among many other languages.
How does my Ruby code tell Chrome what to do?
Your Ruby script uses the Selenium WebDriver gem, the client library. That library sends commands using a standard protocol like the W3C WebDriver protocol to a browser-specific driver like Chrome driver. That driver is a separate little program that actually controls the Chrome browser itself.
Got it. Script to library to protocol to driver to browser.
That's the chain.
And the big wins for Selenium.
It's open source, which is huge, widely supported across languages, browsers, operating systems, great for cross-browser testing, making sure your app works in Chrome, Firefox, Edge, etc., and a massive community.
What about the downsides? Limitations?
Well, it's only for web apps. Can't test native mobile or desktop apps. It doesn't do reporting itself. You need a test framework like RSpec for that.
And tricky web elements.
Yeah, it can struggle sometimes with really dynamic content, things inside iframes, pop-ups, or stuff like KPT-CHAs or video players.
How do Rails developers usually plug this in?
Typically using gems. You'll have Selenium WebDriver, your test framework like RSpec, and crucially, Capybara.
Capybara provides the nice, readable API for tests.
Exactly. Fill an email with user@test.com. You tell Capybara to use Selenium as its driver for tests that need full browser capabilities, especially JavaScript execution.
To test those rich front-end interactions or workflows.
Right. And sources like BrowserStack really stress testing on real browsers and devices, not just simulations.
For maximum accuracy.
Yeah. Emulators and headless browsers are fast for CI, but they don't perfectly match real-world rendering or performance. Real device testing catches issues you'd otherwise miss.
Wow. Okay. That was quite the journey through the realities of using Ruby on Rails.
It really covers the spectrum, doesn't it? From that initial developer joy and speed.
Right.
Through the very real challenges that pop up as apps grow and hit production scale.
And the challenges touch everything. Code performance, database management, testing strategies, dependencies, security, the whole deployment pipeline, and then scaling it all up.
But the main takeaway shouldn't be fear, right? It's that these challenges are known, they're understood.
And there are solutions.
Exactly. Proven patterns, tools, best practices, smart querying, caching, background jobs, solid testing with tools like Selenium and Capybara, robust deployment automation. That's how successful teams manage it.
So understanding the hurdles, but more importantly, knowing the strategies to clear them. That's key.
It's the difference between a quick prototype and a lasting, scalable application.
Which kind of brings us back to that core trade-off, doesn't it?
I think so.
Given the known scaling challenges, but also the tools and community focused on solving them. Is choosing Rails really about its absolute peak performance?
Or is it more about optimizing for developer happiness, that speed of iteration, the agility you get, especially when you're trying to build something new and compete?
Something for you to think about as you plan your next project.